here is do this application of the sum rule. The first problem is a problem where we have two disjoint events. What does disjoint mean? Disjoint means that there is no intersection. So I'm going to write that down, even though you really don't have to each time, is that the intersection is equal to the empty set. That's the empty set. So that the probability of that intersection in this case is the probability of the empty set, which is 0. Now, that is the intersection. So here, this is what they look like. Here's E and here's F. We could color those in because it's fun. That's disjoint. Okay, then what we're looking for is the union. So now the union is what I'm drawing here by the yellow. One way you can think of this is area. The area of the whole room is 1 or 100%, and now we're trying to find the area of these two together, which is union. So there is no overlap. Intersection is overlap. It's all the things that are in E and at the same time as in F. There's no overlap. That's why we're saying that area, which is the probability, is 0. All right. So going on here to what the question asks for, they're asking us for the probability E or F, and OR corresponds to union. So I will write down the union symbol, and then I will use the rule, which is the sum rule, for probability, and I'm going to use the rule for the special case where the two sets are disjoint. Now, it's given right above here that the probability of E is 0.25 and the probability of F is 0.45, and it's embarrassing if I get this wrong, but I believe that's 0.70, which can be, if we feel like it, expressed as a percent. I'll just clean that up to make it look more like equals. All right, so that's what we get for that first part. That's because they're disjoint. Now in this case, probability E and F is 0.1, so that means they're not disjoint. It means there is this overlap that is 0.1. So if this is S, here's E and here's F, and then right here is E intersection F. Now, still what we're going to do is we're going to find the area of this union. We're going to find the area of the union, and what we're going to use is the sum rule, the general sum rule, which says the probability of E or F, which is union F, is equal to the probability of E plus the probability of F minus the probability of the intersection of E and F. And then we can just use the numbers that we have above. The probability of E is 0.25. Probability of F is 0.45. And then in this problem, for problem B, that intersection is 0.1. So if we think in terms of area, the area of E is 0.25, the area of F is 0.25, and that overlap intersection is 0.1. And if we just add the area of E and the area of F, we're going to get an overlap. We're going to get that intersection counted twice. So we don't want to count twice, we want to count once. So we'll subtract off one of those. And if we put that in the calculator, or whatever way we add that up, that is going to make 0.7 minus 0.1, and that makes 0.6, and that's 60%. All right. Now, this right here is a typo of this equals, but anyway, E complements the complement of E, and it's actually sort of an easier problem, but, well, I don't know. Maybe they're all about the same. Okay, here's E. E complement is everything that's in S but not E. So I will color in the part that we're trying to find the probability, which is the area. There's this idea of this is called a measure. There's the probability can be measure, and this fits into this whole part of math called measure theory. So, all right. So the probability, all right, now look, if you look at E and you find that area, and you look at E complement and you find that area, that should add up to the whole area of this box, which is S, and that whole area is supposed to be 1 or 100%. So we can see that the probability of E plus the probability of E complement should add up to 100%. So how can we put that together? The probability of E complement is going to be 100% minus the area probability of E. But I won't put 100%, I'll just put 1. So E has probability of 0.60. So if the chances of E happening are 60%, then the chances of E not happening are 1 minus 60%. Which is 40%. We never said what E is. Maybe E is the chance of rain. So if there's 60% chance of rain, E complements not rain. So if there's 60% chance of rain, then the chance of not raining is 40%. Okay, so that finishes problem number 4, and I don't know what else to say about that. Okay, so that's all for now. Goodbye.